Welcome to today's lesson. This is still lesson 7.4, adding and subtracting polynomials. This will be lesson number 2. You will need your 7.4 practice worksheet for this example. We're just going to run a couple examples. We're going to look at the 2 word problems on the bottom of that worksheet, and then you'll have some practice problems to work on. Remember, the idea here is what rules do I apply when adding and subtracting unlike terms, and I have exponents in those terms. So that's what we need to keep in mind through this section here. So let's start out, just a refresher from yesterday's lesson. We have a polynomial. It's not a quinnomial. It has 4 terms to it. All right, and then we also have a trinomial. So we're subtracting the trinomial from the polynomial itself. Remember from yesterday, we needed to distribute that negative sign. So we're going to bring down that first polynomial. This is in what we call descending order by the exponent. And now distribution. Negative times negative is a positive 4k. Negative times a positive is a negative k squared. And the negative times the negative gives me a positive 3. So let's collect together our like terms. We only have one k to the 3rd power, so we're going to bring him down. We can't add him together with the squares or the single k's because remember, under addition or subtraction, they have to share the same combination. I do have a negative 2k squared, and I do have a negative k squared. They are the same sign, so we're going to sum them together. So negative 2 minus 1 is negative 3, so I had negative 3k squared. I have a couple k terms. So I have a positive 4 and another positive 4k, so it gives me plus 8k. And then finally a positive 6 and a positive 3, which gives me a positive 9. This is simplified. Unless I know the value of k, there's nothing else I can do with this term, okay, with this expression. So remember, I can't add these together. I could multiply them, but the operation is addition or subtraction, and so I can't do that in this example here. So let's take a look at this one. This guy has 3 different expressions. They are all joined by addition. All right, so there's nothing new here. All I'm doing is collecting together those things that are alike. Now I have 3 different variables, an x, y, and a z, so I can only collect x's with x's and z's with z's and so on. So since I don't have to worry about distribution, then I only need to bring those things together that are alike. So I have a 2x, 4x, and a positive x over here. So 2 plus 4 is 6, plus 1 is 7x. I have a positive 6y, I have a negative 8y, and I have a negative, 3y. Sorry about that. See if we can move that back up in there. So altogether, I have 6 minus 8, which is negative 2, and negative 2 minus 3. Negative 2 minus 3 is going to give me a negative 5y. Looking at my z's, I have a negative 3z, a positive 6z, which is going to give me a positive 3z. And then I have one more z here, so positive 4z. Final answer. Can't collect those together. Our last example, though, is 3 polynomials where I do have subtraction between each of the second and the 3rd polynomial. So I do need to do distribution. So I'm going to bring down the first polynomial, and then I'm going to distribute that negative throughout the first group. So that negative 5f squared, negative times a negative gives me a positive 1. Negative times a positive gives me negative 2f. Distribute the negative through the second polynomial, so negative 2f squared. Negative times a negative gives me a positive 3, and negative times a positive gives me negative f. So if I'm looking for all my f squares, I have 3 f squared terms. 6 minus 5 is 1. 1 minus 2 gives me a negative f squared. Looking for my f's. So here's a negative 7f, a negative 2f, and a negative f. Negative 7 minus 2 is negative 9. Negative 9 minus 1 is negative 10f. And then last, we have negative 3. We have a positive 3. And there is that hidden little 1 right inside there. Well, the negative 3 and the positive 3 are going to cancel each other out. So all I have left is the positive 1. So with that, let's take a look at the next two word problems. So where might we see this? So the polynomial s cubed minus 70s squared plus 1500s minus 10,800 models the profit of a company. So this is how much money the company would make in selling the item S. The second item sold at the same price brings in a profit of s cubed minus 30s squared plus 450s minus 5,000. You're asked to write a polynomial that expresses the total profit from the sale of both items. Well, profit is, how much money am I making? And they're looking for total profit. So right here, this is going to tell me I'm going to add my two items together. So if we're thinking about how it was written in our examples, here's my first polynomial. And this is one expression. And I'm going to add to that my second expression. So the parentheses are used to just show grouping. And in this case, they are representing each of the items, how that math expression relates to here's item 1 and here's item 2. Now, because it is a profit, we're adding them together and they're looking for a total, so we're going to add them together. So I have 2s cubes. I have negative 70s squared and negative 30s squared. So this probably is some sort of cost that I have involved in here. So we took care of those. We have 1500s and 450s, so that we add those for 1950s. And then I have the subtraction of these two numbers here, and so that's going to give me 15,800. So this expression here represents the profit that the company will make on these two separate items. So parentheses are used just to group to show item 1 versus item 2, and the operator between the two is that idea of finding its total. Let's take a look at the last example. So here we're looking at a triangle. So in our triangle, we have side 1, I have side 2, and I have side 3. Well, they give us side 1, they give us side 2, but we don't know side 3. So if we think about this problem, the measures of two sides of a triangle are given. If P is the perimeter, and remember, perimeter is the sum of the three sides, or the sum of all sides. Okay, so P, perimeter, is the sum of all sides. So the sum of all sides really would be side 1 plus side 2 plus side 3. Well, I know side 1 and side 2, I just don't know side 3. They tell us that P is actually equal to 10x plus 5y. That P is the sum of all three sides. So this guy right here belongs in the P. Okay, so we can say that 10x plus 5y is equal to sum 1 plus sum 2 plus sum 3. Okay, but I know what sum 1 is, and I know what sum 2 is. I'm going to put those in there. So side 1 is 3x plus 4y plus, because I'm going to bring down that plus sign, side 2, which is 5x minus y. But I don't know side 3. Okay, he's my unknown. But remember, the idea is I'm solving for the unknown. So I need to isolate this guy right here because he's the guy I'm solving for. What does he look like? Okay, so on this side over here, I can collect all these things together. This looks just like a problem that we've done yesterday. I'm adding these two polynomials together. Remember, the parentheses only show the grouping. They are just representing that idea of side 1 and side 2. So I'm going to collect them together. So I have 8x, and I have 4y minus y, so I have a 3y. I still don't know side. But remember, I want to isolate side 3. I want to get him by himself. So we know to isolate him, we're going to move this guy over here. So we're going to subtract him we're going to subtract the 8x plus 3y from the other side. So I have 10x plus 5y minus 8x plus 3y equal to S3. Now, you could have moved them over individually, like we did all in the fall. That would have been fine, but the idea here is that I need to distribute, so 10x plus 5y minus 8x minus 3y, which would have been the same had I just subtracted them over using our old knowledge. And so collecting together those things that are alike, 10x minus 8x is 2x, 5y minus 3y is 2y, and that is equal to side 3 of my polynomial, of my triangle. Okay. Your homework is to complete the evens on the 7-4 practice worksheet 2 through 20. Good luck.